In this video, I'm going to show you how to solve and graph inequalities, and stick around because you might be seeing a special guest in just a bit. So example number 1 says, solve the inequality and graph the solution on the number line. To solve this, the first thing we would want to do is subtract 4 on both sides. Then we have 7x is less than or equal to 14. Just a reminder, when I say in this video that we're going to be solving and graphing inequalities, that means that your symbols are going to look like this: less than or equal to, greater than or equal to. Now with equations, we just have one solution, but with inequalities, we're going to have many solutions, and that's why we graph them on a number line. So to finish off solving this one, we're going to divide both sides by 7, and we get x is less than or equal to 2 as our solution. So notice, if it was an equation, we would just have x equals 2. Now the solution to this inequality is all x values that are less than 2 or equal to 2. And the way that we would graph that is showing that x could be equal to 2, you put a closed circle on 2, and then because x could be any number less than 2, we shade all the numbers to the left, and then I put an arrow saying, you know what, it'd be all the numbers to the left of 2 would be solutions, including 2. So once again, that's what sets equations apart from inequalities. Inequalities often have many solutions, and equations often have one solution. Here we're going to see something interesting happen. So here, when we solve this one, we're first going to subtract 73, and then we have negative 2x is less than 4. At this point, we need to divide both sides by negative 2. Now there's something very important that happens when you are solving an inequality and you divide or multiply by a negative number. And I'm going to bring in our special guest to let us know what that important point is. All right, Molly, what must we all remember? Oh, if you divide or multiply an inequality by a negative number, we need to, she said, flip that sign. So here the sign is going to flip to x is greater than negative 2, and this is going to be our answer. Now, hey, it was just getting good. No yawning. Okay, Molly's going to explain why. So what did you say, Molly? So she's going to explain why we change the sign when we multiply or divide by a negative. So Molly says that the number 2 is greater than 1. So if we were to multiply both sides by negative 1, I would now have negative 2 is greater than negative 1. Yeah, Molly, I agree. Negative 2 is definitely not greater than negative 1. And that's why here, in this case, we multiplied both sides by a negative. We do need to flip that sign to less than to make the inequality stay true. Thanks so much, Molly, for your help. So if I want to graph x is greater than negative 2, to indicate that x cannot equal negative 2 this time, we're going to put an open circle on negative 2. Unlike the last example when our value could equal 2, we put a closed circle. Here it can't equal negative 2, it can only be greater than negative 2. So we indicate that we don't want to include negative 2 by putting an open circle, and then it's all numbers greater than negative 2, and with an arrow, and so it's all shaded to the right of negative 2. Now, I want to make an important point here. Notice that Molly said it's when you divide or multiply by a negative number. Let me show you an alternative. What if this equation had been 2x plus 77, what if this inequality had been 2x plus 77 is less than 73? And let's say we subtracted 77 first to get 2x is less than negative 4, and then we divided both sides by 2. This time we don't have to flip the sign because we're not dividing by a negative number. We're dividing a negative number by 2, but we're not dividing by a negative number. So in this case, you don't flip the sign. So you only flip the sign if you divide both sides by a negative number or if you multiply both sides by a negative number. That's a key thing to remember with inequalities. So remember what Mollee said. And if you're finding this video useful and also liking Mollee, make sure to give this a thumbs up and subscribe so that you can see weekly math videos. In this example, I have one with variables on both sides. Now, which side to put the x on, it's really a personal preference. I always prefer to put that variable on the left side because then it's a little bit easier for me to graph it on the number line. So because of that, I'm going to subtract 10x from both sides and then subtract 5 on both sides. That way I can get the variables to the left side and the numbers to the right side. So now I have negative 14x is greater than or equal to negative 1. I need to divide both sides by negative 14 to get x isolated. And just like Mollee said, don't forget to flip that sign because we divided by a negative number. So x is less than or equal to 1/14. Because x can equal 1/14, I'm going to put a closed circle and just label it as 1/14 so it's apparent. And then all values less than 1/14 are solutions in this inequality. Now, if you actually had put the variables all on the right side and then the numbers on the left side, let me just go through that quick. What you would have gotten when you solve that is you would have gotten 1/14 is greater than or equal to x. And I notice as a teacher when I teach that a lot of times when students leave the variable on the right side, they graph it incorrectly because they actually see this greater than symbol, so they shade to the right. So if you do get this and get a variable on the right side, I would always just flip it around to put the variable on the left. That way you don't make any mistakes when you go to graph it. All right, one more example, and this one has a little more to it. And here you can see that we have 1 minus 3 times this quantity is greater than, and then this right side. So one thing, also a common misconception that I see is students do 1 minus 3 and then they say negative 2 times 4x minus 6. And we need to remember those order of operations. The first thing we do need to do is we need to multiply in this negative 3. Do not subtract 1 minus 3. So I would have 1 minus 12x plus 18 is greater than 9x plus 3 minus 10x. From here, I would combine like terms on both sides of the inequality. We would have 19 minus 12x is greater than negative 1x plus 3. Again, it's personal preference which side of the inequality you would like to put the x on, and I always like to do that on the left side. So I'm going to add the 1x and also subtract 19. Let's come over here to the side, and I would have negative 11x is greater than negative 16, and dividing both sides by negative 11, and since we're dividing by a negative, flip that sign. X is less than positive 16/11. And 16/11 is just bigger than 1. So I'm going to put an open circle at 16/11 because x cannot equal 16/11. X can only be less than 16/11. So x is any value less than 16/11. And then we indicate that on a number line by shading everything to the left. All right, everyone, those are some example problems on how to solve inequalities. And the biggest thing to remember is what Mollee said. If you multiply or divide both sides by a negative number, don't forget to flip that sign. All right, give this video a thumbs up and subscribe so that you can see weekly math videos. Have an awesome day, everyone.